What we have seen in the last class was the bilinear map or fractional linear map. So as the name suggests, the bilinear map is written as W equal to AZ plus B divided by CZ plus D, a ratio of two linear maps. And the point where this map is not analytic is Z is equal to minus d by c. So at all points except Z equal to minus d by c, this map is analytic, and the derivative f dash z will be non-zero if ad minus bc not equal to 0. So at all points except Z equal to minus d by c, this map will be conformal provided AD minus BC not equal to 0. So we restrict AD minus BC non-zero so that this map is a conformal map. And we have seen one property of this map, that is this map preserve cross ratio of 4 points. So if we have 4 points Z1, Z2, Z3, Z4 and their images W1, W2, W3, W4, cross ratio of Z1, Z2, Z3, Z4 will be equal to cross ratio of W1, W2, W3, W4. We make use of this property to find the bilinear map given the images of 3 points. So, given the images of 3 points, the bilinear map is uniquely determined either using the definition of the bilinear map itself and finding ABCD, or directly substituting the values of the given points in this expression. Where W and Z are general points, we take W as the image of Z, W1 the image of Z1, W2 image of Z2, etc. So we make use of this to find the image of, bilinear map given the image of 3 points. Let us see some examples. So we are going to find the bilinear map which maps the points -1, 0, 1, 2, -1, -I, 1. So we name these points as Z1, Z2, Z3 and these as W1, W2, W3. Also we take the general point Z and its image W. So the bilinear map will be of the form W equal to AZ plus B divided by CZ plus D. And as it preserves cross ratio, you can write the cross ratio of W, W1, W2, W3. The cross ratio of the images will be the same as the cross ratio of the 4 points Z, Z1, Z2, Z3. Now let us write this cross ratio and just substitute the points to get W in this form. W equal to AZ plus B divided by CZ plus D. So the cross ratio is W minus W1 into W2 minus W3 divided by, now we interchange W1 and W3 in the denominator. So W minus W3 into W2 minus W1 equal to Z minus Z1 into Z2 minus Z3 divided by, now interchange Z1 and Z3. So Z minus Z3 into Z2 minus Z1. Now let us substitute these points here and write the map. So when you substitute this, we get W minus, W1 is -1. So W minus -1 into W2 minus W3, that is -I -1 divided by, now interchange these 2 points. So the denominator becomes W minus 1 into -I minus -1. And this should be equal to Z minus Z1. Z1 is -1 into Z2 minus Z3 divided by Z minus, now interchange these 2 points, so Z minus 1 into 0 minus minus 1. Now let us just simplify this and write this. So we have W plus 1 into minus of 1 plus I divided by W minus 1 into, here minus into minus 1 becomes 1 minus equal to Z plus 1 into minus 1 divided by Z minus 1 into 1. Now let us first simplify this expression and then cross multiply and write W in this form. ഈ ഫോമിലേക്ക് മാറ്റി എഴുതണം. So to simplify this, we can write the right side as, the left side as W plus 1 into minus of 1 plus I divided by W minus 1 into 1 minus I equal to Z plus 1 into minus 1 divided by Z minus 1. Z plus 1 into minus 1 divided by Z minus 1. So here itself you can cancel this negative sign. Now to simplify this, we first simplify this expression by multiplying with the conjugate of the denominator. So we can write W plus 1 into 1 plus I into conjugate of the denominator as 1 plus I divided by W minus 1 into 1 minus I into 1 plus I. This is equal to Z plus 1 divided by Z minus 1. So we have W plus 1 into 1 plus I square. So 1 plus 2I square is minus 1 divided by W minus 1 into 1 plus I into 1 minus I is 1 minus I square is minus 1. So that is equal to Z plus 1 divided by Z minus 1. So look at this expression. This is W plus 1 into 2I, right? 1 and minus 1 cancels, divided by W minus 1 into 1 minus minus 1 is 2. So you can cancel this 2 also. This is equal to Z plus 1 divided by Z minus 1. Now at this stage we can cross multiply this and simplify. So cross multiplying, we get W plus 1 into I into Z minus 1 equal to Z plus 1 into W minus 1. So take all the terms in W. So W into IZ minus 1 from the left side, and from the right side the terms in W are minus Z plus 1. Taking to the left side, Z plus 1 becomes minus Z plus 1. Now on the right side we have minus of Z plus 1. We have taken the term in W to the left side and there remains minus of Z plus 1, and taking 1 into I into Z minus 1 to the right side, we have minus I into Z minus 1. Again simplifying this, we get W into Z into I minus 1, then see here it should be IZ minus I. Sorry. So minus of 1 plus I minus 1 minus I this equal to, on the right side, minus z into 1 plus I, minus z minus iz. Then here we have minus 1 plus I. So minus of 1 minus I. And hence you can write W equal to minus z into 1 plus I minus 1 minus I divided by minus z. I am taking a minus sign outside to write this in the same form. Minus z into 1 minus I minus 1 plus I. So this is of the form az plus b divided by cz plus d. You may keep it as it is, or you can further simplify it by multiplying the conjugate of these numbers. So I am going to multiply it with 1 minus I throughout. So we have minus z into 1 plus I into 1 minus I makes 2. So I am going to multiply with 1 minus I. 1 minus I. So while you do this, you should do it in the denominator, every term in the denominator as well as in the numerator. So minus of 1 minus I square is minus 2I, and here minus z into 1 minus I square, which is minus 2I. Then minus of 1 plus I into 1 minus I is 2. So suppose I cancel this minus 2 throughout. I get this as z minus I. Minus 2 പോയി കഴിഞ്ഞാൽ ഇവിടെ z ബാക്കി ഉണ്ടാവും, ഇവിടെ minus I ഉണ്ടാവും, divided by, the denominator becomes minus iz plus 1. What I cancelled is minus 2. So taking minus 2 from here, it should be minus iz plus 1. So this is the map which maps the point 1 to 1, minus 1 to minus 1, and 0 to I. Now you can check it, 0 to minus I. So after getting this expression, you just check whether what you obtained is a correct expression by substituting the following. For example, if you give the value 1 for z, we get 1 minus I divided by 1 minus I, which is equal to 1. So the image of 1 is 1. Similarly, if you give z the value 0, you get minus I divided by 1, which is minus I. So the image of 0 is minus I, and so on. You can check whether your answer is correct. So this is one way of finding the bilinear transformation given the image of 3 points. Now, you may also find the bilinear transformation by just substituting the values the points and their images. For example, find the bilinear transformation which maps the points are minus 1 I 1 2 0 I infinity. So we may start by taking, let W equal to az plus b divided by cz plus d be the bilinear transformation. So it means that from the given information, when you substitute z as minus 1, you should get 0, W as 0. Giving z the value I, you should get W as I itself. Giving the value 1, you should get W equal to infinity. So from this, substituting z as minus 1, we get 0 equal to minus a plus b divided by minus c plus d. Z is given the value minus 1 and there the value of w should be 0. And for this to be 0, we know it implies minus a plus b equal to 0, which implies b equal to a. And suppose you take the next point. So when z is equal to iz plus b divided by, ia plus b divided by ic plus d. Z is substituted as I. Then W also should be equal to I. So we get cross multiplying minus C plus ID equal to IA plus B. And we know two complex numbers are equal if and only if their real part and imaginary part are the same. So from this we get B equal to minus C, right? And D equal to A. So now if you go for the last one, when Z is 1, W should be equal to 0. So what we get is 0 equal to, we are giving Z the value 1, so A plus B divided by C plus D. So this implies, W is infinity. So this is infinity means C plus D should be equal to 0, which implies C should be minus D. And we are trying to find all values in terms of one of the variables. So B is equal to minus C. This implies from this you can write C equal to minus A, D equal to A. So C equal to minus A, D equal to A. What we get in the last equation is the same expression, C equal to minus D. So at this stage itself you can write the bilinear transformation. So now we write W equal to AZ plus B. B is A divided by CZ. C is minus A and D is A. So we get the transformation by cancelling A as Z plus 1 divided by minus Z plus 1. Now just substitute and see whether we are right or wrong. When Z is minus 1, we get this as 0. When Z is 1, the denominator becomes infinity. 0, so that W is infinity. When Z is equal to I, we get 1 plus I divided by 1 minus I, which on simplification you can see that is equal to I. So this is another way of finding a bilinear transformation. So we can either use the method of direct substitution or the method of cross ratio to find the bilinear transformation given the image of 3 points. Now let us do one more question in this. So find the bilinear transformation with fixed points plus or minus I. So we know for fixed point the image will be that point itself. That means I is mapped to I, minus I is mapped to minus I. So we are not given 3 points, we are given the image of 2 points only, and we will find the bilinear transformation up to the information given. So we start by taking the bilinear transformation W equal to AZ plus B divided by CZ plus D, right? And I is mapped to I, so we have I is equal to AI plus B divided by CI plus D. And minus I is mapped to minus I. So we can write minus I is equal to minus AI plus B divided by minus CI plus D. So this implies on cross multiplication minus C plus ID equal to AI plus B, and thus on cross multiplication gives minus I into minus I, again minus 1, so minus C minus ID equal to minus AI plus B. So from this you can equate C as C equal to minus B, D equal to E, and this also gives the same information only, C equal to minus B, D equal to. So we will substitute what we obtained in the transformation. So our W was AZ plus B divided by CZ plus D. So we can write W equal to AZ plus B divided by CZ is CS minus B, so minus BZ plus DS equal to. So you may take that B outside and cancel it. So if you take B outside, we get A by B Z plus 1 divided by minus Z plus A by B. So you can cancel this B and we can write this as some kz plus 1 divided by minus Z plus K, for K is a constant. We have no restriction on K. For K, any constant, this, what is K? K is A by B. So, kz plus 1, whatever be the value of K, this map W equal to kz plus 1 divided by minus Z plus K will have plus or minus I as its fixed point. So, given the image of 3 points, you can find all the arbitrary constants, all the constants A, B, C, D uniquely. Given the image of 2 points, there remains one arbitrary constant in the bilinear transformation. So you just write for any value of K, this will be a bilinear transformation with fixed points plus or minus. So these are the things I wanted to discuss in bilinear map, and we have one special map of special bilinear map which is mentioned in your syllabus, which is 1 by 7.